Hi, and welcome to Early Age Mathematics, a voyage of discovery. The name of this talk is a tribute to the great child psychologist Jean Piaget, who also happened to be an expert in early age math education. Piaget taught us, among other things, that whenever we teach children something new, we deny from them the opportunity and the pleasure of discovering this thing on their own. Today, we're going to talk about a system called Matific that we developed in order to help teachers teach and students learn mathematics. And this principle of self-discovery is inherent in the Matific pedagogy, as we'll see later on during the talk. I'm Shimon Shoken, and this talk was prepared together with my colleague, Raz Cooperman. Now, both Raz and myself believe that our role as teachers is to empower children to learn mathematics using their own devices. And when we say devices, we mean not only their laptops and tablets, but their cognitive devices. I've been spending more than 30 years developing software, methodologies, contents, lots of contents that help children and adults learn computer science and mathematics in a process of self-discovery. And you can watch some of my TED Talks and a course that I teach on Coursera that illustrate these pedagogical principles. And this is Raz, my colleague, who up until a few months ago was director of the world-famed Einstein Institute of Mathematics. In addition for being an accomplished mathematician, Raz is also a renowned guru in early age math education. And during the last 8 years, Raz and his team have trained hundreds of teachers how to teach math effectively in elementary school. This is a subject about which Raz also wrote several textbooks, and he also has a course in Coursera about Introduction to Mathematics. The talk that we prepared consists of 4 independent parts, each being about 10 to 15 minutes of video. You can watch these parts separately, but of course we'll be glad if you watch all of them one after the other. So here's the problem. At some point in junior high, we give students this right-angled triangle and ask them to compute x. Well, one of the students comes back and says, "You wanted me to find x? Here it is. I found it." Well, this is an old joke, and I'm repeating it here just for your entertainment. But seriously, we do have a worldwide math education crisis. Now, at least part of the problem is because teachers in first grade and second grade, who are otherwise excellent teachers, simply don't have formal math education. They are not prepared to teach math. And it's almost as you would ask someone who never touched a musical instrument to teach music. It's very difficult to do. And therefore, there's no wonder that many teachers, like their students, suffer from math anxiety. There's also a problem with students' attitude. At the beginning of their education, in kindergarten, first grade, students actually like math. But at some point, typically when fractions enter the picture, children begin to lose confidence. They go through the motions, they divide fractions somehow, they multiply 3-digit numbers, and they come up with the right answers, but they have no idea why these procedures and algorithms actually work. And this is kind of scary. Now, we developed Matific in order to deal with some of these problems. And in this talk, we are not going to walk you through the process of actually using Matific. We have a whole set of tutorials that deal with functionality and usage, but rather we are going to focus mostly on the underlying pedagogy of our approach. Now, before we actually give you a demo of how Matific works, I'd like to say a few words about how teachers use it in the classroom. So what we see here is a teacher who uses Matific in order to simply introduce a new subject in mathematics. So she connects her laptop or her tablet to the projector and introduces the subject using an example or a game or some engaging interaction. And good teachers typically call students to the whiteboard or the smartboard, it doesn't matter what you have, and they involve the students in the process, which makes it more engaging and more fun for the rest of the class. Now, these two modes of usage can be done even if you have only one laptop or one tablet in your classroom. even with this setting, Matific is incredibly beneficial for your teaching. But if you have access to more devices in the class or in your school, then you can let children practice Matific during the class, or you can use the software after class for one-on-one intervention to close gaps with some of the students, or you can use Matific to give your students numerous homework assignments which they're actually going to enjoy, and they will enjoy them because Matific is a lot of fun. Let me give you an example. This episode helps children practice counting, but at the same time, it also sets the stage for addition. And as you know, counting and addition are the two most fundamental skills that children are supposed to acquire in preschool and first grade. Matific has about 30 episodes that deal with counting and addition, and this is one of them. So let's see, we have a string and 2 balls full of beads, and we are asked to create a necklace using exactly 4 beads. All right, let's do it. 1, 2, 3, 4. Done. And now I have to create a necklace using 7 beads. 1, 2, 3, 4, 5, 6, 7. And hey, I have all these green beads here and I really didn't use them so far, so let's put some greens also. 1, 2, 3. But wait a minute, I now recall that I have to use 7 beads only, so if I put 3 greens, I have to get rid of 3 reds. So 1, 2, 3. So let's see, how many do we have altogether? 1, 2, 3. 3 greens. 1, 2, 3, 4. 4 reds. 1, 2, 3, 4, 5, 6, 7. Looking good. I bet that some of you wonder, if the goal is to create a bracelet with so many beads, why do we need 2 types of beads? Well, this gives us a lot of flexibility because it allows different children to come up with different solutions which are otherwise correct. And in fact, there are 128 different ways to come up with the right solution here. And by comparing these different solutions, you get the great benefit of learning something about addition. You learn that 7 can be 7 red beads, but it can also be 3 greens and 4 reds. It can also be 2 and 5, or 5 and 2, or 1 and 6, or 6 and 1. So you also learn something about commutativity. And of course, you learn a lot about patterns. And it's up to the teacher if he or she wants to discuss patterns using this episode as well. So as many other Matific episodes, this episode has more to it than meets the eye. Now, some teachers who look at this episode would say something like, well, it's kind of cute to play with a computer, but wouldn't it be much more fun if the students could actually build these bracelets using, a real string and real beads? Well, the answer is, it may be fun, but if the goal is to teach mathematics, then the simulation is far more effective than the actual experience with physical objects. And research actually supports it. Compared with the physical counterparts, computer representations are more manageable, extensible, and free of distracting features, says one article about the subject. And here's another quote. The physicality of learning object is not important. What's important is the ability to manipulate them and to derive meaning from this activity. Okay, we mentioned the word episode many times, and I'd like to say a few words about what I mean when I say a Matific episode. Well, an episode for us is a hands-on minigame that consists of some scene or a familiar context and some objects that can be manipulated. And these manipulations are driven by a set of questions or tasks which are presented to the student. The whole thing lasts anything from 10 minutes to 30 minutes of interaction, and it is highly adaptive. so that different students learn in a different pace. They get different questions according to their revealed ability. And as teachers, it's very important to know that all these episodes are richly indexed on your curriculum or teaching plan or your popular textbook. So it's very easy to find episodes which are relevant to what you want to teach. Now, we developed numerous such episodes. In fact, I think that by now we have more than 1,000 episodes and interactive worksheets available in Matific. And some people sometimes tell us, why do you develop so many episodes? Well, the answer is that, first of all, we enjoy it, but more seriously, in order to get a deep understanding of mathematics, which is mostly an abstract subject, you have to see many concrete examples. And in the rest of this talk, in parts 2, 3, and 4, we will go through many more examples of Matific episodes, and we'll talk about how they can affect the way you teach math in your classes.